and I'm particularly pleased to welcome such a great audience. It's interesting to know what attracts people, isn't it? And I hope that my husband said to me that I'll have to repeat the sex and violence in my subsequent lectures this year as well. That might be more tricky. We're looking at where bodies might have gone to, or alternatively come from, if they've been found. And I want to take you really from the details of particular cases to the general principles of tracing bodies. And just to paraphrase a popular TV series, I like to think of the river as a silent witness, because there are clues we can use and evidence that we can gather to establish more about what may have happened or what cannot have happened in particular circumstances, so that we can help the police. People believe, apparently, that rivers and canals are discrete places to dispose of incriminating evidence. Now, when I visited the site, it was impossible to measure the flow rate with conventional means because it was just too slow. But what I managed to do was to use some biodegradable dye to measure the velocity. And of course, it didn't answer the question about whether he was pushed or had fallen in or anything of that sort, but it did rule out some possibilities for the police. To get a fuller picture about bodies in rivers, we'd have to add in suicides as well, but I'll say a little bit more about that in a minute. But I had actually, and this sounds rather strange as well, I had some experience of teaching undergraduate students about the flow dynamics of rivers by floating a few of them, alive, I should say, down the river, in the River Severn in wetsuits whilst on a field trip. And so I used to tell them, hold hands, and when I say go, let go, and the rest of us will watch what happens. And we used to watch them float off down the river and see what was happening to them. So I told him that I'd never tried tracing dead bodies, but I'd be willing to have a shot, and that I liked a challenge, and it grew from there. And I've now advised on about more than 20 fairly significant cases since then. Now, as a general principle, there are various things involved in undertaking an inquiry, from understanding what you're being asked to do through to satisfying the client that everything's been done and presenting the case possibly in court as an expert witness. I also want to share with you some of the instructions that I get, and this is an example of an early one. And if you look at what it says in the facts, so this is going back ancient technology here, it says, "Ray our body found in the River Thames. When can you start? How long it would take? What will it cost? And do you need to know the weight?" So there actually aren't, it doesn't tell me what I'm supposed to be doing. It just says, what will it cost? And when can you start? So although there is a question, there's clearly a question. A body had been found in the river, and they basically wanted to know, in that case, where it had, that was a case of where it had come from. Now, some cases, of course, are not murders. As I mentioned earlier, some are clearly suicides, and some are the loss of children or non-swimmers in exceptional circumstances. This one here, which we'll take a first look at, is again somewhere that may be broadly familiar to you. This is again on the Thames at around about Eton. This is Boveney Lock here. This is the Thames running down into London, and the body was found floating in the river by a rowing team, actually. This is a situation where the body was lost, and the police were keen to know where to start the search. I beg your pardon, I think I've got that the wrong way round. A body was found, in this case, the police wanted to know where to start to look for where they'd gone into the river. Now, underwater search teams are expensive to deploy. Searching rivers in flood is difficult, and it's very dangerous. And anything that can be done to work out the maximum distance that a body or parts of the body, or a body in a suitcase, as we'll come to in a minute, might have travelled in a specific time period is very welcome. So the more typical inquiry actually is a body's been found and the police need an indication of where it's come from. And I should say it's very far from being an exact science, because we often can't replicate the thing experimentally. I can't reconstruct what was going on in terms of the flow of a river just like that. What I have to do is to get the best possible information and use some judgment. If I was going to explain, build a model of exactly what happens to a body in a river, I'm going to divide it into 4 phases really. It's what happens when it enters the river, and then what happens when it decays, and how does it get into the flow and move, and how does it land somewhere if it's actually found on the bed of the river or on the river bank or something like that. And in fact, the body was not in the river, they found it buried in some adjacent woodland. So some criminals are actually quite clever, but not all. Okay, now, let's just look at the body entering the water. And we have to understand a little bit about what happens when a body enters the water. Now here, you can see here, I'm very grateful to the Institution of Environmental Sciences for drawing me these diagrams, but here you can see a body entering the water, and it's going to go down through the depth of the water, which can be any kind of depth. Bubbles are going to come off it, it's going to sink to the bottom at least initially, and it's going to end up a little bit further along the river from when it went in because of the shape and the clothing and the density of the body. So it's going to end up probably on the bed of the stream. There's the obligatory shopping trolley, of course. And then it's going to start to decay. And the rate of decay of the body is going to be affected by the temperature and the size of the body, and it's going to generate a volume of gas in the body, now particularly in the torso. Not anywhere else in particular, but in the main chest or abdominal cavity of the body, because those are where there are voids. But at least initially it's going to sink to the bottom of the stream. And the rate at which that decay takes place is quite variable, but this is the sort of time we're talking about. So first of all, what we get is something called washerwoman's fingers after a few hours in cold water. These are timescales typical for the UK. If we were in the tropics or the sea, it would be much faster. But we get some decay within a few days. It starts to look a bit older within about a week, and then within a couple of weeks it's starting to get seriously deteriorated, and then we hit this bloat, what the analysts call bloat, where we've got gas formation in the abdomen and thorax, and that's a variable amount of time. And then finally, after some weeks, months, depends on the temperature, the thing will become a skeleton, will start to fall apart. So this is a bit grisly, I know, but you have to understand that, because that's what's going to influence what happens to the body when it goes into the river. Now, of course, my evidence is not the only scientific evidence that's used. All sorts of evidence is used. Here's some University of Warwick academics. They, in this particular case, analysed the breakages in the bones and identified the saw that was used, which is on the right-hand side there. Other cases use things like diatoms that get caught up in the clothing of somebody that's thrown in the river. And you can see here that diatoms in water come in different forms. We've got here freshwater ones and brackish or saline water ones from the Severn Estuary. So by analysing what's caught up in the clothes, pathologists can work out whether the body has, for example, been in salt water in an estuary or has been only in the fresh water. Similarly, this is pollen. Many of you will know that pollen grains are very easy to identify, many of them, and again can identify whether a body was in perhaps a rural setting surrounded by, say, grass grains, wheat or something like that, or in an area where the pollen is diverse, very diverse, where there are maybe exotic garden plants. Okay, so that's another possibility. Look away if you don't like this. Insect infestation. I'm just looking to see who has looked away. Nobody, actually. Insect infestation can indicate, this is a piece of human body, can identify whether or the length of time that a body has been exposed to the air. And occasionally you get other bits of evidence. I will mention later, in a few minutes, a case where a body was impaled with a piece of wood that turned out to be a branch from an exotic tree, and the police managed to find the right garden where it had come from. what happens when the body gets up into the flow? Okay, now, what actually happens, and here's our erstwhile body again, is that river velocities, particularly in flood conditions, they move relatively slowly near the bed, and they move much faster towards the top. The peak velocity is just below the surface, actually. And what happens with this is that two things. First of all, you've got gas in the body, and secondly, this is like an aeroplane lift, and as the water flows over the body, it tends to draw it up into the flow, and therefore at this point it rises up and goes along with the velocity of the water. So the thing that would dictate how far it got would be whether there were any obstacles in the way, and we can look at that in a minute. Grounding, what happens to it at the end of the pathway. In this particular case, it could be some time later, or it depends where the body's been in the interim, but we've got a body, perhaps I've described it here as losing its integrity. The gas has come out, it's rotted through, it falls to the bed, or it could be trapped behind an obstacle, or it could be trapped in sediment, or along the side of the river, or in a vortex at the side of the water, at the side of the river. Now, if it's the water's very turbulent, or it's saline, or it's very cold, the water is more denser, and the body is going to float more easily. So we've got quite a complex modelling job here to work out where the body might go in this particular instance, and where it might be redeposited. Now, using that information, on the second run the next day, also high tide, we managed to reconstruct the pattern exactly, and we were able to establish that the body had gone into the river here and had gone upstream right up here and then back down again and grounded here. So we managed to do it exactly. And from that data, I gave the police a time of release and a place of release in Great Yarmouth. And fortunately, the police had actually, and remember now 6 months has gone past because of the tidal cycles, the police had archived some CCTV footage from a doctor's car park, a waiting room car park. But they hadn't analysed it all because they'd got lots of this stuff. They'd archived all CCTV footage from all over, everywhere actually. But they managed to analyse it. And I gave them the time window, a 10-minute time window, and I said, look at this 10 minutes here. And they looked at the CCTV footage and they saw a car go down to the river in the window I'd given them. And after the CCTV footage was cleaned up, they could read the number plate. And I can tell you now, there's my analysis. I won't bore you with the timing, but it was the husband that did it. Thank you.